Bismillah wassalatu wassalamu ala rasulillah amma ba'd. Hello everyone, I am Mohammed Alhibshi, biomedical engineering student at King Abdulaziz University. Today I will present the theory, instrumentation, and some technical specification of the medical linear accelerator. The theory behind the LINACs. A medical linear accelerator LINAC is a radiation therapy equipment that produces constant intensity of photon beams, X-rays, or electron beams in different amount of energy to treat cancer cells and tumors. The LINAC equipment uses a radiation frequency, RF energy source, to generate radiations that destroy the DNA material inside the nucleus of the cancers and slow the growth of the tumors, while avoiding harming the healthy cells near to the cancer cell. LINAC is also using an accelerator guide to deliver the appropriate amount of radiation at the appropriate time. The instrumentation of the LINAC. As can be seen in the picture, there are four main components of the LINAC. The components are the modulator, electron gun or E-gun, radio frequency power source, and accelerator guide. The modulator amplifies and rectifies the power from AC pulses to DC pulses to power the electron gun and radio frequency RF power source with high voltage and high current pulses. The modulator is located either in gantry stand or in a separate stand. The electron gun or E-gun is a source of electrons that insert electrons in the appropriate position, velocity, and duration to the accelerator guide. The electron gun depends on the thermonic emission to generate the electrons. The heat is generated to release the electrons from the surface. E-gun or the electrode gun consists of some parts. First, a cathode is emitting electrons if heated using a heater. Second, a control grid that controls the electrons flow. Third, a focus electrode that forms the shape of the electron beam. Fourth, an anode as a ground. Electron gun could be permanently attached to the accelerator guide or could be removable for easy replacement. The radio frequency RF power source is generating a microwave power and deliver it to the accelerator guide. The radio frequency source works with some elements that help and control the LINAC to work properly as follows. A circulator to control the power flowing from the RF source and protect from reflecting power. A load that capable of absorbing any reflected power. An automatic frequency control that feeding back and synchronizing the frequency of the source and other units in the LINAC. The RF source is divided into the megatron and clusteron, as we will see in the next slide. The megatron is a type of microwave generator that generates power of about 2.6 megawatt and adjusts the frequency from almost 2993 to 300 megahertz. Also generates photon beam from 4 to 10 megavolt and electron beam from 9 to 15 million volt. Since the megatron works as an oscillator, it only needs a DC power to provide the energy and does not require an RF input signal. The megatron structure is, as can be seen in the picture, is a central cylindrical shape cathode surrounded by an anode that has the identical cylindrical pattern organization cavities. Electrons are generated using a thermonic emission mechanism when the cathode is heated. Here in these two pictures we can see on the right the schematic of the magnetron, and in the left we can see the actual magnetron. Now for the clusteron. The clusteron is a type of microwave generator that generates power of about 7.5 megawatt with 2998.5 megahertz operating frequency. Also generates photon beams from 15 to 25 megavolt and electron beams from 4 to 22 million volt. Since the clusteron works as an amplifier, it requires an RF input signal, usually called RF driver, beside the need of the DC power to provide the energy and amplifies the low RF power. The clusteron structure is a tube organized as a straight line shaped with RF cavities and has a cathode using the thermonic emission mechanism to generate the electrons. Here in these two pictures, on the left we can see the actual clusteron, and on the right we can see the schematic of a clusteron. In the clusteron there are two basic cavities, the bencher cavity, which take the energy from the RF driver and energize using the low RF power, the catheter cavity, which emits the high RF power by extracting the power from the microwave beam energy. The accelerator guide. The accelerator guide is a structure composed of several copper with microwave resonant cavities to accelerate the electrons with the required amount of energy. There are two types of accelerator guide: standing wave accelerator and traveling wave accelerator. The traveling wave guide accelerator have a cavity of accelerator reasoning and developing the microwave through the accelerator tube. While the standing wave type make the accelerated microwave oscillating inside a sealed tube from both sides, causing microwave reflections which increase the intensity. The treatment head. The treatment head consists of elements that ensure delivering suitable amount of radiation into the target area of a patient. These elements as follow. The tungsten target, which converts the electrons to the photons or X-ray radiation. After the radiation passes the target, it's spread in various directions, so a primary collimates and make the radiation to travel in forward direction, causing a cone-shaped beam. Also, it determines the maximum size of the output radiation. The flattening filter, which modifies the beam shape from cone shape to more uniform shape. The ion chamber is measuring the dose and monitor the beam quality passes through it. The multi-leaf collimator consists of numbers of tungsten leaf. Each move along to create numerous radiation shapes which match the shape of the affected area on the patient. Now with some technical specification of the LINAC. According to the International Atomic Agency and World Health Organization. We can see, for example, the maximum beam area is 40 by 40 centimeter and the minimum area is 4 by 4 centimeter at the isocenter. 6 millivolt photon energy with a flattening filter, an isocenter motorized gantry with plus minus 180 degree rotation, variable photons dose rate from 50 to 400 million per minute. A treatment couch is capable to take weight of at least 180 kilogram. And these are some, not all, the specification of the LINAC. So this is the end of the presentation. I hope you enjoyed the presentation. Thank you for your time.